Hi everybody, Johnny here. I hope you're doing great today. You'll find more good math at jmathpage.com. Today we're looking at multiplying 5's, and we're going to be using something special called scaling. So I'm going to explain what scaling is. Scaling is about stretching things out or shrinking things. But let's have something to shrink and scale and make bigger to start with. So I'm going to start with a line just down here. I'll make this line just 1 unit tall. It's just 1, so I'll call it 1. Now from everything that I do now, it's going to be measured against this 1. So that's a good start for me. Now what if I wanted a line that was twice as tall as this? Well, I would have to go twice as tall, right? So I'd have to go 1 times as tall as the first, and now 2 times as tall as the first. And this line here is twice as tall as the first line, and this is only 1 times as tall as itself. Okay, so far so good. What happens if I go and want to make it 3 times as tall? Well, let's start here. I can start here, and now I have to count up. First, this is just 1 times as tall as the beginning. 2 times as tall. Now this is 3 times as tall as the first line that I drew. 3 times as tall. So I'll mark that. 1, 2, 3. This is only 1. So this is 3 times as tall. What about 4 times as tall? Let me start down here, and we'll count up. 1 times as tall, 2 times as tall, 3 times as tall, 4 times as tall as the first measure. All right. We can see how much taller it is already. What about the next one? Start down here. So 1 times as tall, 2, 3, 4, 5 times as tall as the first measure. So 5 times as tall. Compare 1, 2, 3, 4, 5, whereas this is only just 1. What about the next one? Let's start here. This is now just the same height as the first one. This is 2 times as tall, 3 times as tall, 4 times as tall, 5 times as tall, and now 6 times as tall as the first line. 6 times. Okay. The next one. Start down here. Let's count up again. 1 times as tall, 2 times, 3 times, 4 times, 5 times, 6 times, and 7 times as tall as the original measure. 7 times as tall. So look how tall this one is now. 7 measures, whereas this is only 1 measure. Over here, 1 measure, 2, 3, 4, 5, 6, 7, 8 measures tall. 8 measures tall. 8 measures tall. So this line here is 8 times as tall as the first measure. 1 more. Start here. 1 measure, 2, 3, 4, 5, 6, 7, 8, 9 measures tall. That's the tallest of all, isn't it? So it's 9 times as tall as the first measure. So that's what scaling looks like. But what does it look like when we're talking about multiplying 5's? Let's try it out. Let's see. I'm going to put down here a set of 5 boxes. Okay, so there's 5 boxes right there. And if we look, when we measure just 1 stack of 5 boxes, we have 5 boxes, right? Now, how many boxes will I have if I make 2 stacks of 5 boxes when I stretch this to be twice as tall a stack? Let's find out. Here's 1 stack of 5 boxes and a second stack of 5 boxes. How tall altogether? Well, 5 and 5 more. That gives us 10, doesn't it? So this stack of boxes has twice as many boxes altogether than the first stack. What about 3 times as high? 1, 2, 3. So I have 3 stacks of 5 boxes. Okay. How many boxes altogether? Well, 5, 10, 15 boxes altogether. So this stack has 3 times as many boxes as the first stack, right? 3 times as many. How about 4 times 5 boxes? Well, here we go. 1 stack of 5, 2 stacks of 5, 3 stacks of 5, 4 stacks of 5. How many boxes? 5, 10, 15, 20 boxes altogether. 4 times as many here as here. 5 stacks of 5 boxes. 1, 2, 3, 4, 5 stacks of 5 boxes. How many boxes altogether? 5, 10, 15, 20, and 5 more gives us 25. 5 times as many boxes here as here. Okay. What about 6 stacks of 5 boxes? 1, 2, 3, 4, 5, 6 stacks of 5 boxes. How many boxes altogether? 5, 10, 15, 20, 25, and 5 more give us 30. 6 times as many boxes here as in our first stack. Okay. 7 stacks of 5 boxes. 1, 2, 3, 4, 5, 6, 7 stacks of 5 boxes. How many altogether? 5, 10, 15, 20, 25, 30, 35 boxes altogether. All right. Now we have to make an even larger stack. How tall is this one going to be? Let's count. 1 stack of 5, 2 stacks of 5, 3, 4, 5 stacks of 5, 6 stacks of 5, 7 stacks of 5, and 8 stacks of 5 boxes. How many altogether? 5, 10, 15, 20, 25, 30, 35, and 5 more. 40 boxes. That's quite a lot of boxes. 8 times as many here as in our first stack. Let's make the tallest one now. 9 stacks of 5 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9 stacks of 5 boxes. How many boxes altogether? 5, 10, 15, 20, 25, 30, 35, 40, 45 altogether. So this number of boxes is 9 times as many as in our first stack of 5 boxes. So it's grown and grown and grown in size. So let's think about that for a moment when we think about scaling. Scaling is something special. So let's start here at the 1 again. We started at the 1 and we grew to twice as many. Then we made our stacks 3 times as tall, then 4 times as tall as the first one, 5 times as tall, 6 times as tall, 7 times as tall, 8 times as tall, 9 times as tall as our first stack. It's growing and growing and growing. So we can think about scaling as things growing and growing and growing. And you can imagine it getting taller and taller and taller after this too. So scaling can be thought of as things growing, but it can also be thought of as things shrinking. So if we think this way, we're growing, but what happens if we go this way? Things are shrinking, 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 shrinking. So if we look at 9 stacks of 5 boxes, if we shrunk it down to here, this is only one part of 9 stacks of 5 boxes. Look how tiny this is. This is a small piece of this one, and that's shrinking. We can also see it here. If we have 6 stacks of 5 boxes, and we shrink to half that size, we only have 3 stacks of 5 boxes. And we can look at 6 stacks of 5 boxes is 30, but half as many is only 15. So scaling means things growing and growing and growing in multiples, getting bigger and bigger, or shrinking and shrinking and shrinking the other way. So scaling is a useful idea in multiplication. I hope this has been helpful to you.